Hello everyone, especially my beloved sister. This is Priscilla, and this video is about vector dot product and matrix multiplication. I am assuming that people watching this have a background of vectors, like they know what a vector is, they know magnitude and direction and everything. To calculate the dot product of x and y, we multiply these corresponding elements. So it will be x1 times y1 plus x2 times y2 plus x3 times y3. And this will give you a number. Let's do an example. We will just do these two elements multiplied together plus 5 times 3 plus 2 times 0, which are these elements correspondingly. That will be negative 3 plus 15 plus 0 equals to 12. This is how you do a dot product. What does a dot product measure? A dot product measures how similar two vectors are, and this is because dot product is related to the cosine of the theta between two vectors. For example, here we have vector u and vector v, and this is the angle between them. The dot product of u and v is equal to the magnitude of vectors u and v times the cosine of the theta between them. And if we move things around, we can see the cosine of the theta is the dot product of u and v divided by their magnitudes. And to calculate theta, we can just do our cosine of that thing or cosine inverse of that expression back there. But okay, so how do we get here? How does this expression make sense? A simple proof is this way. So if we have vector u at an angle and vector v kind of aligned with the horizontal, and still theta here, with trig, you can kind of see that we can break down this u vector into a horizontal component and a vertical component. And the horizontal component is going to be calculated as u cosine theta, and the vertical component is u sine theta. This is just basic trigonometry. So now let's write the two vectors as their unit vector representations, basically. So u on the horizontal I hat direction is u cosine theta units of I hat, plus on the vertical direction, u sine theta units of j hat. And for v, you can express it as v, its magnitude, its length, in the I direction, plus 0 in the j direction. And now, what is the dot product of u and v? Let's look back to this definition up here. We can see it will be this element times this element, plus the vertical elements multiplied together, which will be u v cosine theta, plus what is the red part? It will be 0 because there's a 0 in the v. So basically, the dot product is just this expression right here. And this is a proof. And there are multiple ways of proving this. So now we have this theta between two vectors. What does this measure? Like, what does it mean that two vectors are similar to each other? Well, graphically, it means that the two vectors are close to each other. So a bigger theta means that u, v are very apart, and a smaller theta means our u, v are more aligned in the same direction. And a application I can think of this is in natural language processing. So each word is represented as a vector. For example, apple, maybe. It will be a vector of a lot of elements, a lot of numbers, like 100, 1, 2, and so on. And then there will be another word like banana. It will again be a vector. And how similar the word apple and banana are is measured basically by this cosine theta formula of the dot product over their magnitudes. Okay, so now let's talk about matrices. A matrix is basically a bunch of vectors. So let me write this up. You can see that there are 3 rows and 4 columns. So we will usually say that this matrix is of the dimension 3 by 4. But each of these columns and rows are just a vector. So this is a column vector, this is a column vector, this is a column vector, and this is also a column vector. Because you can write a vector in this way and also write it horizontally. They're the equivalent, or write it with angle brackets. And all the horizontal rows are also row vectors. So this is a row vector, 1, 2, 3, 4, this is a row vector, 5, 6, 7, 8, and this is also a row vector. Understanding this will allow us to break a matrix down into vectors, and this way we can perform calculations on the smaller units without worrying about the matrix as a whole. So how do we do matrix multiplication? Let's start with how we do the simplest of all matrix multiplications by definition. So this is a row vector 1, 2 multiplied with a column vector 3, 4. What we do is that we take this first entry, 1 and 3, we multiply them together, and we add that to the second entry, 2 and 4. And this will be 3 plus, 8, which is 11. What does this look like? Yes, it is exactly a dot product, and this is by definition. So to add on to that, let's have maybe 1, 2, 3, 4, and let's just put 5 and 7 here. So how would we do this? Exactly the same. So we do the first 2 numbers here, 1 times 5, plus the second 2, 2 times 7. Notice how we're multiplying the row vector on the first row with a column vector on the right side, and the answer that we get is a number in the first row of the answer vector. So that is a number here. And then we repeat the process with the second row. So that will be 3 times 5 plus 4 times 7. And to draw it out, it is a multiplication of this vector and that vector. And it is exactly the same as how we did the dot product up here. So the answer will be a vector with two values. That's 5 plus 14 and 15 plus 28, which will be 19 and, oh my god, 43. Yeah? Okay. And how do we further expand this? So we have two row vectors here. What if we have two column vectors? Now you see why I did 5 and 7. It is exactly the same. The first column of the answer vector will be the column vector here that we got by multiplying these two together. So the top is 1 times 5 plus 2 times 7, and the bottom is 3 times 5 plus 4 times 7. Then we need to get the result of multiplying the matrix with the second column vector. And how do we do that? We first multiply the row vector 1, 2 with the column vector 6, 8, and that is 1 times 6 plus 2 times 8. Then we multiply the row vector 3, 4 with the column vector 6, 8. That is 3 times 6 plus 4 times 8. And you can see that this will just give you four numbers, the first two of which are these, and the other one is 22 and 50. Hopefully I did the math right, but you see the concept there. So this is how we build up to do matrix multiplications for multiple row vectors and multiple column vectors from only one row vector and one column vector. And let's do another example here. Let's have 2, 3, 4, 7, 5, 9. How do we do this? You take the first row vector, multiply with the first column vector. That is 2 times 3 plus 3 times 2. Now take the second row vector with the first column vector. 4 times 3 plus 7 times 2. Then it is the last row vector with the first column vector. 5 times 3 plus 9 times 2. Repeat that with the second column vector. 2 times 7 plus 3 times 1. 4 times 7 plus 7 times 1. 5 times 7 plus 9 times 1. And repeat the exact same process with the last column vector. 2 times 6 plus 3 times 8, 4 times 6 plus 7 times 8, 5 times 6 plus 9 times 8. Get all those numbers and you have a 3x3 answer matrix. This is how you do multiplication. Congratulations, you learned it. It's very easy if you look at a matrix as a bunch of vectors and break it down this way. And lastly, I want to talk about the easy way to do a transpose. So we just talked about all of these column vectors and row vectors. How do you read the row vector? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? To write the transpose of a matrix, you basically just read its column vectors, and as you're reading them, put them on a row. So you have 1, 5, 9, 2, 6, 10, 3, 7, 11, 4, 8, 12, and that is a transpose. This is the easiest way I can think of doing it. It is not flipping by the diagonal. You just count the column vectors as you're writing them horizontally. That gives you the transpose. And now, you probably know why sometimes the dot product is written as xy transpose. So for example, you have 1, 2 times 3, 4, which will give you 1 times 3 plus 2 times 4, right? And if the x vector is 1, 2, and the y vector is 3, 4, the y transpose is basically, well, the first column vector is a 3, so you write it down. The second column vector is a 4, you write it below that, so it is this. And their product is just 1, 2 times 3, 4, which is a row vector multiplied with a column vector. And that gives you 1 times 3 plus 3 times 4, which is the exact same result as here, and which is also the exact same thing we did as a first step right here. This is why some textbooks teaches that matrix multiplication is just a bunch of dot products. It is just a bunch of dot products, but I think the way that I learned it and I organized it here is just the easiest for my brain, and hopefully it helps you too. This is Priscilla, and see you next time. And if you're my sister, let's get dinner soon.